So we've got a spinner and we can see that it's got 5 equal sections. So let's just write down what the probability of getting red is on one spin. So the probability of getting red on one spin is 2/5 and the probability of getting blue is 3/5. So the spinner is spun until it lands on red or has been spun 4 times in total. So we're not going to spin it more than 4 times. Find the probability distribution of the random variable S, the number of times the spinner is spun. So I'm tempted to draw a little tree diagram just to help us think about this situation. So when we spin the spinner for the first time, we can either get red or we can get blue. So this is the first spin. Now if we get red, then we're going to stop spinning the spinner. But if I get blue, then we're going to spin again. And I could either get red or I could get blue on the second spin. Well, if I get red on the second spin, then I stop spinning. And if I get blue, then I'm going to have another go at spinning and see if I get red again. So I could get red or blue. So this is the third spin. And then finally, if I get red on the third spin, then I'm going to stop. And if I get blue on the third spin, then I'm going to have one last go at trying to get red. So red or blue. Now, because this is the fourth spin, I'm going to stop because it says we stop if it's been spun 4 times in total. So let's write down the probabilities on these branches. They're independent probabilities, so they don't change. And next to each outcome, let's write down what our random variable S would be. So S is the number of times the spinner is spun. So one of our possible outcomes was we just span the spinner once and we got red the first time. In this case, we'd have S is equal to 1 because we did 1 spin in total. Another outcome is that we span blue and then we span red and then we stopped. So here S would be 2 because we've spanned the spinner twice. Another outcome was that we did blue on the first spin, blue on the second spin, and then red on the third spin, and then we stopped. So in that outcome, the total number of spins was 3. And then finally, we've got this outcome here, where we did blue, 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 and then red, and then we stopped. So in this case, S would be 4, and this outcome, blue, 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 and then blue, this outcome would give us S is 4. So what we need to do is we need to try and work out what's the probability of getting each of these values of S. So you can see that the possible outcomes of S are 1 spin, 2 spin, 3 spins, or 4 spins. So let's write down that in a table. So we're going to use a little value of S for the specific values that S can take. And we know that S, the total number of spins, could either be 1, 2, 3, or 4. So underneath, we're going to write what's the probability of getting each of these specific values of S. So if we look at our tree diagram, there's only one way of getting S equaling 1, which is going down this branch and then stopping. So that probability is just 2/5. And that's basically the probability of just getting red on the first spin, and then we stop. There's only one way of getting S equaling 2. That is getting blue on the first spin and red on the second spin. So here we'd have to do 3/5 multiplied by 2/5. There's only one way of getting S to be equal to 3. That would be blue, blue, and then red. So that's going to be 3/5 times 3/5, and then we have to go down this branch to make sure that we get a red one on the third spin to get that. And then the fourth, there's two ways to get S equaling 4. It's this option, this outcome, or this outcome. So the probability of this outcome is 3/5 times 3/5 times 3/5, and then times by 2/5. I'm going to write that as 3/5 cubed, and then times by 2/5. Or we could have this outcome here. So remember, or means we add on the probability of getting this outcome. So getting this outcome is 3/5 times 3/5 times 3/5 times 3/5, which is just 3/5 to the power of 4. And then finally, we should probably simplify this table a little bit and work out what are the values of each of these probabilities. So the probability of 1 is 5/5, the probability of 2 is 6/25, the probability of 3 is 18 over 125, and the probability of 4 is 27 over 125. Now, it's a good idea at the end to make sure that all these probabilities add up to 1. So let's just check they sum to 1, because these are all the possible outcomes of this experiment for our value of S. Now, it's worth noting actually that if you didn't want to work out what this probability was and you knew these probabilities, then in order to find the probability of S equaling 4, you could just do 1 subtract all the other probabilities, because you know the total probabilities have to add up to 1. So here you could have just done 1 subtract the sum of all the other probabilities to make sure that all of the probabilities in the table add up to 1. So that's always an option if you can't work out this final probability.